So let's look at another example. So let's determine the relative extrema of the function 1 minus x squared plus y squared to the 1/3. So again, we're going to start by finding our critical points. So to do that, I need my two partial derivatives. Fx will be negative 1/3 x squared plus y squared to the negative 2/3 times 2x. So I'll just write that to look a little bit nicer. Fx will be negative 2x over 3 x squared plus y squared to the 2/3. And if you find Fy, you'll get something similar. You'll get negative 2y over 3 x squared plus y squared to the 2/3. Now, I need to worry here because I'm dividing. When do I divide by 0? And that's when x and y are both 0. So these two, these don't exist at the point 0, 0. So we get one critical point. Corresponding to 0, 0. And so now I need to figure out, does this critical point give me a relative extremum? Well, let's look what happens. Go back to our function here. If I plug in 0, 0 into my function, it outputs the value 1. And if I plug in any other point other than 0, 0, then my function f of xy, well, it's 1 minus something that's not 0 here. So in the end, it'll be smaller than 1. So for any other point, my function outputs something smaller than 1, which tells me that this right here had to have been a relative maximum. So I can say f has a relative maximum at the point 0, 0.